Hello, everyone, and welcome back again to Across STEM with YSI, where we sit down with the speakers of STEM Quest 3.0 and unpack the ideas that are shaping how we understand science, medicine, and the human brain. I'm your host, Amirali, and today's episode, which is episode 8 of season 2 now, takes us into a topic that is both deeply scientific and also deeply personal, and that is dementia. For many people, dementia is something they've encountered through family, through news headlines, or quite worries about aging. But behind that word is a very wide spectrum of neurological changes that scientists and clinicians are still working to fully understand. To talk about this, joining us today is Cosim, who is a neurology resident at the University of Salerno in Italy, who earned his medical degree there in early 2024 and is now training at the front lines of clinical neurology. At STEMQuest 3.0, Cosimo presented a session on what he calls the phenotypic continuum of dementia, which is essentially a way of understanding cognitive decline not as a sudden event, but as a gradual progression that begins long before a formal diagnosis. In his talk, Cosimo walked us through the early stages of cognitive decline, including the subjective cognitive decline and the mild cognitive impairment before expanding into what dementia actually means as a clinical category. He then zoomed in on Alzheimer's disease, exploring how common it is and what is happening in the brain on a biological level and how doctors currently diagnose and treat Alzheimer's. Today, we'll go into building on that conversation. We'll talk about how neurologists think about dementia in real life, what still puzzles researchers, why understanding this continuum matters not just for medicine, but for how we think about aging and identity. And all along this, we'll learn more about Cosimo himself. So, Cosimo, welcome to Across STEM with YSI. How are you doing today, and where are you joining us from?
Thank you. I'm fine, thanks. So we want to talk about dementia, but in clinical practice. Fundamentally, as dementia is a continuum, we can, there are some early phases before we can call a patient dementia. For example, we have a new construct which was defined very recently, that is about the subjective cognitive decline. So these are patients that they behave, they have some memory issues. My English is not so good. Allora, how do I say? It's a form of cognitive decline when only the patient has subjective complaints about a cognitive decline, so they can claim to have a memory issue. But on neuropsychological testings, which include very forms of tests, they score 100%. They score perfectly, so they do not have dementia for that motive, but there are all these subjective complaints, but the functional activities are retained. So a classic patient with subjective cognitive decline is can be also one of our parents, for example. So they behave perfectly, but they can complain about memory issues and so on. Then we go to mild cognitive impairment, where functional activities are retained, but this patient score below the threshold for cognitive decline. And then we have dementia, where we have, for example, mini mental state examination, which is one of the several tests we can do on a patient with suspected dementia, where they have a quantitative decline which is objectively derived from the neuropsychological battery. Why is this important? This is important as you live in the United States, correct?
Yes.
So you already have a lecanemab or Leqembi, which is a monoclonal antibodies directed to beta amyloids.
Yes.
While in Italy do not have currently disease-modifying therapies. We are still waiting for approval by our FDA, if we can say so. Why this classification matters? This matters as these anticorpal, these drugs were tested in the early stages of Alzheimer's disease or also MCI, mild cognitive impairment. And we can see that these drugs can reduce the grade of disability over years. So we have a scale which is the CDR. The CDR lets us to classify in order of worseness different grades of dementia. So we can have 0.5, 1, 2, 3, and so on for severe until to severe dementia. So we need we have to detect this kind of people so they can access disease modifying therapies.
Interesting. So
I hope
yeah.
I hope the time is late. I'm also very tired, so my English is not so good normally, so it is worse right
okay.
now.
It's perfectly fine. Thank you for that deep explanation about dementia and Alzheimer's and available treatments. And yeah, it's interesting how certain monoclonal antibodies like lecanemab, which can, treat such diseases through targeting beta amyloid proteins, don't exist everywhere, even in Italy, which is, very much an advanced country. It's a first world country, but it still shows how much we need to do to make these treatments widely available. And yeah, I think there's so much work that has to be done. You would know a lot more about this, but there has to be a lot more that has to be done before we find a proper accessible treatment for Alzheimer's. We may have some promising therapies right now, but even if they exist, they're not accessible, and that is a huge problem. And Alzheimer's, for instance, is it's quite a common disease. I mean, every family probably has someone now or in the past who's had Alzheimer's. So yeah, it's a disease it's one of those diseases where if we can find a treatment for, it can be transformative in a way that affects everyone.
Absolutely.
Because it's just so common in families across the world. Now, I want to talk more about how you got into studying cognitive decline and dementia and Alzheimer's. I mean, you're a neurology resident at the moment, and you quite recently graduated from medical school. What drew you first towards neurology, and was there like a specific moment or some kind of events that happened that made you think, oh my God, this is such an amazing field that I want to go into it and study cognitive decline and everything else?
Yeah. Neurology is a very complex matter. I began interested in neurology around my 4th, 5th year of medical school, where when I was very interested in neuroscience, about the human behavior and so on. So being interested in neuroscience drew me to become a neurologist, as a matter of fact. I think that the complexity of neurology is also its beauty. So, because everything. For example, it has a directly correlation with neuroanatomy. For example, when you see a patient with stroke, even without CT scan and MRI, you can visit the patient and find clues for anatomical localization. So it's very complicated, but arriving to a diagnosis is very, very interesting. I have several research projects in reality. I'm not I'm not only interested in cognitive decline, but I also do some research in movement disorders, mainly Parkinson's disease. And right now, I'm very interested in the EEG, electroencephalographic. I don't know how to say in English.
Electroencephalography.
And electroencephalography. So I'm right now training a neural network for classifying EEGs as normal or abnormal. So I'm also dedicating my time to this other research project. It's very ambitious as a project, but I hope I can write to good performance for my algorithms. Speaking of neurology, it was neurology that made me passionate about artificial intelligence. The neurology was the main inspiration, for example, building neural networks. They tend to behave like a human brain, but in a more reduced dimension. So I also studied programming. I program in Python, in R. Very passionate about artificial intelligence, and I hope in the future to apply this knowledge also to cognitive decline. For example, a study about the voice of patients. Maybe we can help us to identify people with a risk of dementia. So this is another research project I'm thinking about in these days. How about you, Amirali? You are doing some research too?
Yes, actually. So I'm currently an undergraduate neuroscience student, and I am involved in a lab where we do work on studying different kinds of therapies for Alzheimer's disease, actually. So related to what you do. And my role in that lab is to produce plots of how amyloid beta levels change. First of all, in disease progression, regular disease progression, and kind of like the control group where you have normal aging and cognitive decline, and how relative to that amyloid beta levels increase naturally as you age. And then we study how different treatments, especially monoclonal antibody treatments, change beta amyloid levels in Alzheimer's disease. I make plots showing how effective they are, and a lot of that data comes from collaborators we have in Roche in Switzerland, the huge pharmaceutical company. So we're doing a lot of work with them, and later this year we plan to publish a paper about this, and I'm going to be contributing to that through the plots that I make, which I'm doing through Python actually as well. So that's the research that I'm involved in at the moment. But I mean, as part of my regular studies in the undergrad level, I study a lot of different things in neuroscience, more general, but I am very interested in this topic of dementia and Alzheimer's, and especially the treatments that we're able to develop for them.
Okay, but for my curiosity, neuroscience is a different pathway from medical school. So it's a sort of biology, because neuroscience in Italy is a second level degree. respect to biology. So you do biology and then do neuroscience.
In the US, it's different. It's you go into undergrad and you choose something to study, a pathway like neuroscience or biology or biochemistry, microbiology, whatever. And all of these usually are pre-med. So you study these and then you go into medical school, which is the graduate pathway you take after the undergraduate pathway. And neuroscience is a very common path that pre-meds take to medical school. It's a different system than Italy and compared to most of the world, I think. In a lot of places, you go straight to medical school. If you want to pursue biology or neuroscience, you do something else and you don't go to medical school. But yeah, in the US, it's very different in that sense.
Very different. Yeah.
Yeah. But yeah, I love learning about, the different systems across the world and how people like you have gone into medical school and now pursuing your residency in neurology and everything and doing more clinical stuff. It's very different, I think, than what we do here and how the educational system here works. I don't know. I don't know which one's better. I think I'm not the biggest fan of undergrads. I think it's just extra things you have to do. But at the same time, if it allows you to explore different areas and it's more flexible if you figure out that like medicine is not for you, you don't want to go into medicine, you can make that decision before going to medical school. So there are pros and cons. Yeah. So that's how it is here. Now I have a question for you about your STEMQuest 3.0 session, and that is you kind of introduced this idea of a phenotypic continuum of dementia. And I briefly introduced that in our introduction for this episode, but for people who are listening and who haven't encountered this term before, how would you describe what a phenotypic continuum of dementia is in plain language?
As I said before, we have subjective cognitive decline, mild cognitive decline, and then we have dementia. The main differences are that in mild cognitive impairment we do not have a functional impairment, but we have while in subjective cognitive decline we only have the complaints from the patient that come to us. For example, complaining about recent loss of memory and so on. What can I say? Do you have any questions about my presentation?
Yeah, I mean, one question that I do have is that in cognitive decline and mild cognitive impairments, what are some of the earliest clues that neurologists look for in these cases?
So the main complaint is memory. For example, in mild cognitive impairment, we can have a only memory related problem, so we call it amnesic MCI, but we can have also the damage on other functional levels. For example, language, we can have a language impairment, for example. In practice, the patients come to us, we do a screening test, which is the mini-mental state examination, and from this stage we have to exclude other forms of dementia, for example, lewy body dementia, frontotemporal dementia, which have a different type of medical history, but also a different type of complaints. For example, frontotemporal dementia is a form of dementia that goes to, how can I say this? It's a frontotemporal dementia in the sense of only the part of the frontal lobes and temporal lobes are from this pathology. And so we have a different clinical aspects. For example, in frontotemporal dementia, we have a behavioral abnormalities, as this disease cause a lesion, a degeneration of the frontal lobes that we know are very important for planning and for inhibiting inappropriate behaviors, for example. There is also another form of dementia, which is vascular dementia. Vascular dementia is another type of disorder where we have more investment in the executive function. So we have to do this differential diagnosis, and we usually request to our patient to do an MRI, because first of all we do not only have to recognize other forms of dementia, but you have to identify also secondary forms of dementia. For example, I think a frontal mass, for example, a temporal tumor, or we can have a alteration in thyroid levels. Hypothyroidism can also mimic a form of cognitive decline, and for example also vitamins B12 deficiency can cause an impairment in the functional in the executive functions. So I don't know if you are understanding what I'm saying, because I'm saying very. I don't know. Are you interested in asking something? I don't know.
Yeah, I mean, when it comes to diagnostics, that's something I'm really interested in. I know that a lot of diagnostic approaches are evolving, from imaging to biomarkers to cognitive testing, etc. And I'm curious, what tools are neurologists relying on today mostly, and where do you see diagnostics going in the next decade in terms of the tools that we use, in terms of accuracy, or even new tools that come out for diagnosing these diseases more accurately and early on, and even predicting their onset better?
There are many studies where with the help of artificial intelligence we can predict the risk of dementia from in a multimodal way. For example, by integrating not only imaging but also clinical data, tabular data. There are these tools that can predict dementia from MCI and so on, between the other forms of dementia. About the future of neurology, I think that every neurologist must have a background on artificial intelligence, because it's very close to us. For example, neuroradiologists use a software, an AI software, for calculating volumes of lesions, of hemorrhagic lesions, for example. So we already have an integration of an AI systems in our clinical
practice.
Exactly, practice. There isn't for every pathology, but I think in the near future, maybe 3-5 years, we could have these systems also for not only dementia, but for example for epilepsy, for movement disorders, for example for detecting tremor or myoclonus and so on. So I think every neurologist must also be a programmer, idea. Instead, have a knowledge about how this AI system works, because you have to comprehend the source before relying on it. So we must be very careful about these things.
And I mean, from diagnostics, we go into treatment, which is a whole other world, much more complicated world, of course. And I want to know, as someone who is in this field and studying it at the moment, and you're involved with, you're exposed to the latest research, the treatments for Alzheimer's and related dementias, they really remain some of the biggest challenges that exist, not only in neurology, but in medicine as a whole. How do you think, in your eyes, the current therapeutic landscape is, and what gives you hope about future progress that we make in this area?
I think that the introduction of disease-modifying therapies is an incredible thing, because neurology is also a field where we have many pathologies for which we cannot reduce the progression of the disease. For example, amyotrophic multiple sclerosis, for example. So having a drug that can significantly reduce the onset of dementia is very, very important. It has an impact. It's a very, very important matter. Also because it can boost, I think, also the discovery for drugs for Parkinson's disease, for example. Another pathology, another disease for which we do not have currently a disease-modifying therapy. So I think that Alzheimer's is only one of the milestones that can guide us to produce other drugs. For Alzheimer's disease itself, for example, we have not only monoclonal antibodies directed to beta amyloid proteins, but are in development also drugs that target the tau protein. So I think that in the future we have these two drugs. We target beta amyloid, but we also target tau. And in this way, we actually can stop the progression of disease.
Absolutely. Yeah, I think in that sense, I mean, if we target all these proteins whose aggregation leads to plaques and the progression of disease like Alzheimer's, it's a more holistic approach that considers everything, every factor that can contribute to the disease onset and progression. And with that, we can make more effective therapies that are able to eradicate or at least slow the progression of Alzheimer's disease much more quickly, much more effectively, and without a lot of side effects, hopefully.
About the side effects,
yeah.
We can have important side effects. For example, lecanemab can cause the amyloid-related changes in the brain in the form of a brain edema or a brain hemorrhage.
Right.
And this type of lesions can be disidentified as, for example, a stroke, an hemorrhagic stroke. Instead, I do not have to treat this patient as an hemorrhagic stroke, but it's a patient who is taking these monoclonal antibodies. So these two aspects are very important, as this type of drugs tend to have, especially in a subpopulation, which is in homozygosis for the gene epsilon, as there is a risk of hemorrhages in these patients respect to heterozygosis. So we must stay in the track to treat these patients. But we also must be very cautious about the side effects, in particular those on the brain itself.
Absolutely. Yeah, that's side effects is a whole other kind of issue to deal with, because, I mean, goes with not just neurological treatments, but for a lot of other diseases. You can't just see what the solution to a problem is without considering the other problems it can cause. So minimizing side effects itself is a hugely complicated thing that you have to keep in mind when developing treatments, especially for something like Alzheimer's, which is very complex, as is anything that has to do with the brain and the nervous system as a whole. So finally, I want you to give some advice for students who might be fascinated by neurology, but who are unsure of where to begin with, whether in this advice can be in research and clinical training, public communication, anything that you've done and that you think you can provide great advice about, please do so.
Well, practice makes perfect, as we can say, and neurology is practice most of all. And there is the research part, obviously. I think that neurology right now is a field where that is thriving on research on multiple aspects. So, a student that wants to become a neurologist must they have to think that they are going to a I don't know, it is a residency also in
Yes,
USA.
yeah.
They must be fascinated by I mean, how can you not be fascinated by the complexity of the brain?
Of
So
course.
I think if someone wants to not only know about the brain, but also in practice what we can do to these patients, what diagnosis we can do, and which treatment to do, I think neurology is a great subject. For example, neuroscience is a more a lab, correct me if I'm wrong, is more lab related.
Lots of
You do experiments on animal models
yeah.
and so on. So if you are a person that wants to do research but that can have an impact on our patients, I think neurologist is a good subject to study. Absolutely. Just don't be scared from the complexity of the brain. As the brain is very complex, also the diseases are very complex and are different patient from patient. Every patient have a subkind, a phenotype of a disease, which can be different from another patient. This means that therapy also must be tailored to the patient itself. And I think that in the future, also with the help of precision medicine, we can produce tailored treatment for most of our patients. The only bad side of neurology is that, as I said before, we do not have a treatment for most of our diseases. So it can be very challenging by confronting a patient with a neurodegenerative disorder, as you have to communicate the diagnosis which has a
Yes.
an emotionally it requires a great heart,
Yeah.
because we have to exactly we have to understand the how much a disease impact on the life of a patient.
Absolutely.
For example, multiple sclerosis, it can affect people around 25, 27 years old, and this type of disease can be disruptive on the functional side for this patient. So, for example, in multiple sclerosis, we already have some tailored therapy. So, if you love the brain, follow the the neurology path, if you are interested also in clinical practice. Then after, for example, I intend to become a doctorate after my graduation from the residency. Maybe I will enter the field of neuroscience. I'm very interested also in the lab work, which we do not do in our years of clinical practice. It's only clinical practice, not experiments on animal models, which is for me very interesting as a matter.
Yeah, well, maybe we can work together, one day in a lab.
Absolutely. So I have to complete other 2 years of neurology residency. But maybe one day you will be the neuroscientist and you will teach me how to do things in the lab.
In the lab,
absolutely.
Yeah. For sure, I'd love to. Yeah, but even, you say like the lack of treatments that exists at the moment for neurological diseases, it's a problem, but I think it's part of what makes it exciting because there's so much room for discovery, so much room for growth in this field, so much room for innovation.
Yeah.
Unlike any other field I can think of, honestly. It's just, it's kind of daunting that, after all these years of intense research by different teams and collaborators across the world, we still haven't been able to, we've made a lot of progress, don't get me wrong, of course, but we haven't been able to come up with a good, effective treatment for a disease like Alzheimer's. At the same time, for those who are entering this field, you could be the person who discovers a treatment, a properly
absolutely, but you are the person that will test these drugs on patients. For example, in our school, we have very several numbers of drug trials. We test this drug, which are mainly monoclonal antibodies, for example, for Parkinson's disease, and we directly participate in research in this way. So there is a room, there is a space, a very large space for whoever wants to do research. Because research in neurology is exploding. Like I think cardiology, for example, dermatology. I do not think these are subjects where research is going on so much faster with so much participation. It's truly a matter on its own for research.
Yeah, neurology, it's ridiculous how much research is happening, and for good reason, because there's a ton of more things we need to discover in this field, and a lot more we need to innovate until we get to that treatment for Alzheimer's, for dementia, and all the neurological disorders that are so incredibly complex. But yeah, thanks to people like you, we're getting there, and hopefully again we can work together towards that goal. Cosimo, thank you so much for
Thank you. Sorry for the English.
All good, don't worry about it. And I know it's late night there, you're tired, but thank you so much regardless for joining me on this podcast where we explored the phenotypic continuum of dementia and a lot more, from early cognitive changes and the dynamics of it to Alzheimer's disease and the hope for treatments that we have. I really enjoyed this talk as someone who is very fascinated by this field myself, and as someone who's trying to get more involved in it. I really enjoyed it and I learned a lot from you, and I hope the listeners also really found this valuable. And again, thank you so much for sharing your insights as a neurology resident, as someone who is doing clinical training and who is very deeply invested in understanding, not just the brain and cognitive decline and the mechanisms behind it, but also how we are able to treat these diseases and how diagnostics and therapeutics are changing day by day, really. And what stands out to me mostly from today's conversation is how human neurological science is, how memory and your identity are intertwined, how early changes matter, and even how the process of asking better questions can be transformative ultimately for patients, for caregivers, and the broader field. So continue being curious, continue asking questions and doing research and learning more about these diseases and how they're caused and how we can treat them. And eventually, hopefully not too far in the future, we can discover a proper cure that is accessible for everyone and that can be transformative to so many lives. Cosimo, before we wrap up, is there anything that you'd love to leave our audience with? Maybe a message for young people thinking about neuroscience, medicine, the future of health, or for those maybe who are hopeful for a treatment in Alzheimer's?
I think I can summarize it in a phrase. Be curious. Exactly. Be curious, be a person that makes her own questions itself, and tries to find an answer to these questions. So be curious. This is the catchphrase.
Absolutely. What a way to...
Curiosity is the first thing of creative. Also,
Of course, yeah, definitely. What a way to end the session. I mean, whoever's watching, I hope you took notes of that last message. Be curious because, I mean, everything we know, everything we've discovered, everything we've innovated has come from curiosity, asking questions, and never letting yourself be bound, by any sort of fear for being wrong, any sort of fear for not understanding something properly. As long as you're curious, that's what matters the most, and you will learn more than you ever would have without asking any questions. So thank you for leaving us with that message, Cosimo, and I hope you have a great night.
thank you. Thank you, Amirali.
Of course. Talk to you soon.